6 flashes of light erupted on the surface of the moon, while 4 astronauts floated in total silence behind it, 252,000 miles from every other human being alive. Nobody on Earth knew. Nobody could know. The crew of Orion, Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen had slipped behind the lunar horizon and disappeared from all contact. 40 minutes of communications blackout stretching between them and the rest of our species, like a wall no signal could penetrate. Mission Control had their telemetry from before the blackout began, and they had the memory of a voice and nothing else. 4 people, farther from home than any human being in the entire history of our existence, watching rocks from deep space slam into the ground below them in silent bursts of light and dust and heat, with no way to tell anyone what they were seeing. The astronauts themselves struggled to describe it afterward. One of them said simply that there are no adjectives. Another said that humans have probably not evolved to see what they were seeing, not as a poetic flourish, but as a genuine observation, the kind you arrive at when language stops working, and you are left holding an experience that your mind was never designed to process. 6 confirmed impact flashes during a single 7-hour flyby, each one a rock arriving from somewhere in the deep solar system, and ending its journey against the lunar surface in a fraction of a second, visible as a point of light from 4,000 miles above. The moon is not the calm, familiar, well-understood place that decades of photographs and textbook diagrams have led most people to quietly assume it is. It is a surface that gets hit, regularly and without warning, by objects traveling at speeds that dissolve stone into plasma. And on April 6th, 2026, 4 people were close enough to watch it happen, alone in a way that no human being had ever been alone before. If you enjoy what comes next, consider subscribing and leaving a like. We begin now. To understand what that distance actually means, you have to start with what we had before. The record for farthest any human being had ever traveled from Earth belonged to the crew of Apollo 13, set in April of 1970, during a mission that nearly killed everyone aboard. Jim Lovell, Jack Swigert, Fred Hayes, 3 men trying to stay alive inside a crippled spacecraft, swinging around the far side of the moon on a trajectory that was itself the emergency. The only path home available to them after an oxygen tank exploded 2 days into the flight. They reached 248,655 miles from Earth. That record stood for 56 years. And then, on April 6th, 2026, the crew of a spacecraft named Integrity passed it, kept going, and reached 252,756 miles. The margin between those 2 numbers is 4,111 miles. That sounds like a rounding error at this scale, a negligible difference between 2 enormous figures. But 4,111 miles is roughly the distance from New York City to Berlin. It is the width of the North Atlantic Ocean. If you climbed into a commercial airliner and flew east from New York, crossing the ocean at cruising altitude, you would land somewhere over Central Europe before you had covered that margin, that sliver of additional distance that separates what humanity had done before from what Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen did on that morning. The gap between the old record and the new one is not a rounding error. It is a transatlantic crossing. It is a continent and an ocean combined. So think about where that leaves us. 252,756 miles is the distance at which 4 human beings floated inside the Orion spacecraft named Integrity, looking down at a surface 4,000 miles below them, farther from every other member of their species than any living thing with a nervous system had ever been in the entire documented history of human presence on this planet. And during the 40 minutes they spent behind the moon, completely out of contact with mission control and with every other human being alive, there was no phone call they could make, no radio signal that could reach them, no text message, no transmission of any kind capable of crossing the wall of the moon and finding them on the other side. The people at Mission Control in Houston had the data from before the blackout began. They had the last known positions, the last confirmed readings, the memory of a voice. And then they waited. 40 minutes is not a long time in most contexts. It is a lunch break, a commute, a television episode without commercials. but 40 minutes of total silence when 4 people are 252,000 miles away, behind a body large enough to block every signal humanity knows how to send, is a different kind of 40 minutes. There is nothing to do. There is no partial signal, no delayed update, no garbled transmission through the interference. The blackout is complete and structural. The moon itself is the barrier, and the moon is 800 miles across and does not negotiate. Mission control sits, and the clocks run, and the consoles show whatever they showed before the crew disappeared. And the only thing anyone can do is wait for the spacecraft to emerge from the other side. While they waited, on the surface below, rocks were hitting the moon. During that single 7-hour flyby, the crew of Integrity confirmed 6 separate impact flashes on the lunar surface. 6 distinct moments where something arriving from elsewhere in the solar system ended its journey against the moon in a fraction of a second. 2 of those 6 flashes occurred during the blackout. When the crew finally emerged from behind the moon and communications restored, they reported what they had seen, and Mission Control heard it for the first time with a 40-minute delay already built in. The accounts of explosions that had already happened and been witnessed and absorbed before anyone on Earth knew to listen for them. Each of those impacts involved an object traveling at more than 40,000 miles per hour. That is not a number that translates easily into anything familiar. The fastest a commercial airliner moves is roughly 600 miles per hour. A rifle bullet moves somewhere around 2,000 miles per hour. An object hitting the moon at 40,000 miles per hour is moving at more than 20 times the speed of a rifle bullet. Fast enough that the collision itself generates temperatures comparable to the surface of the sun. Fast enough that solid rock does not crack or shatter or crater cleanly. It vaporizes. It flashes into plasma. It converts directly from stone into light and gas in a duration too brief to measure by any instrument a person could hold in their hands. And the crew of Integrity watched 6 of those events happen during the span of a single working day, from 4,000 miles above in complete and total silence, with nothing but the windows of the spacecraft between them and the open vacuum where those flashes were still cooling. 6 impacts during 7 hours. That is not what most people would predict if you asked them what a flyby of the moon would look like. And that question, whether 6 is a lot, whether 7 hours is typical, whether the moon is being hit the way they watched it being hit on a routine basis, or whether April 6th happened to be extraordinary, that question does not have a comfortable answer. The honest answer is that 6 impacts in 7 hours is not extraordinary at all. It is, by any reasonable measure of the data, a fairly ordinary afternoon on the moon. NASA has been watching the lunar surface for impacts since 2005, using a pair of 14-inch telescopes at Marshall Space Flight Center in Alabama, pointed permanently at the moon, cataloging every flash of light that might indicate a rock arriving from elsewhere in the solar system. Over those 2 decades of observation, they have logged more than 443 candidate impact flash events, and that number represents only the flashes large enough to register, only the objects substantial enough to produce a visible burst of light against the dark portions of the lunar surface, only the events that happen to fall within the field of view of instruments designed specifically to catch them. The European Space Agency runs a parallel program called Neliota, operating out of the Crioneri Observatory in Greece through a 1.2-meter telescope, and between February of 2017 and August of 2023, Neliota validated 192 separate lunar impact flashes independently. 2 programs, 2 continents, 2 decades, 2 different telescopes, and they are finding the same thing. The moon is being struck constantly. The number that matters most is 7.4. That is the baseline rate derived from all of this monitoring data for sporadic meteoroid impacts across the entire lunar surface. 7.4 strikes per hour under ordinary conditions, climbing to 12.6 per hour during meteor showers when the Earth and Moon pass through the debris trails left behind by comets and asteroids. The Perseids come from the trail of Comet Swift-Tuttle. The Geminids come from the asteroid designated Phaethon. The Leonids come from Comet Tempel-Tuttle. Every year, predictably, reliably, the planet and its companion orbit through clouds of material that have been waiting in those paths for millions of years, and the rate climbs from 7.4 to 12.6, and the surface of the moon receives that increase in silence and without complaint. Sit with that number for a moment. Every hour, nearly 8 rocks from deep space strike the lunar surface. There is no siren, no warning, no sound. 7.4 per hour means roughly 1 impact somewhere on the moon every 8 minutes, around the clock. Not just during flybys, not just during meteor showers, not just on days when instruments happen to be watching. Every 8 minutes, something from deep space ends its journey in a fraction of a second against the lunar surface. That has been happening for approximately 4.5 billion years. There is no particular reason to think it will stop. Now here is where the picture becomes genuinely unsettling, because the natural assumption when you hear a number like 7.4 is that the objects doing the striking must be substantial. Rocks large enough to explain the violence of those plasma flashes, boulders or at least fist-sized chunks of stone. The data says otherwise. Between 75 and 80% of all impactors that hit the moon are under 200 grams in mass and under 3 centimeters in radius. That is a rock the size of a golf ball. The kind of thing you would pick up on a hiking trail without really thinking about it, turn over in your hand for a moment, and toss aside into the brush. A pebble, essentially. An object that, if you found it on the ground beside your car, you would not bother to move. At the velocities these objects travel, a pebble becomes something else entirely. The range of impact speeds documented in the monitoring data runs from 20 to 72 kilometers per second, which translates to between 45,000 and 160,000 miles per hour. A golf ball traveling at 160,000 miles per hour does not behave like a golf ball. It does not behave like anything you have a word for. At that speed, the kinetic energy stored in 200 grams of rock is comparable to the energy released by a small explosive device. Not a metaphor, not a rhetorical exaggeration, but a direct physical equivalence that engineers who design spacecraft hulls and lunar habitat walls have to calculate explicitly. The flash temperatures produced at the moment of impact range from 2000 to 4500 Kelvin. Steel melts at around 1500 Kelvin. The surface of the sun burns at approximately 5800 Kelvin. A pebble, 200 grams, the kind of thing you would kick aside without a second thought, strikes the lunar surface and for a brief duration creates a point of heat that approaches the lower range of stellar temperature. A tiny, violent, instantaneous star blooming in the dust and dying before any instrument could hold it. During the Artemis II flyby, the Unistellar Citizen Science Network coordinated amateur astronomers around the world to observe the lunar surface alongside the professional monitoring programs, adding additional pairs of eyes to the data being collected in real time. The crew of Integrity, 4,000 miles above the surface, was watching from above. Telescopes in Alabama and Greece were watching from below. Amateur observers on multiple continents were watching from their own backyards. And still, across all of that observation, the rate came out close to what the models predicted. Because the bombardment is not a random spike or an unusual event or a consequence of some temporary disturbance in the solar system. It is the baseline condition of a world with no atmosphere. And that is the distinction that carries the real weight here. On Earth, 48 tons of space debris enters the atmosphere every single day. The shooting stars visible on a clear summer night, those brief bright lines crossing the sky, are tiny fragments of rock and metal burning up roughly 60 miles above the surface, vaporized by friction before they can reach the ground. Most of them are smaller than a grain of sand. The ones large enough to survive the descent and actually strike the surface are rare enough to make the news. The atmosphere is doing enormous work, constantly, silently, without any acknowledgement from the people living beneath it. It is converting potential catastrophe into a light show. The moon has no atmosphere. Not a thin one, not a partial one. The moon has essentially no atmosphere at all, which means that every object that crosses its path, every gram of comet debris, every chip of asteroid, every piece of ancient stone that has been drifting through the inner solar system since before the Earth existed, arrives at the surface at the exact velocity it carried through open space. Nothing slows, nothing burns away. Every one of those 7.4 rocks per hour hits exactly as hard as physics requires. So when you stand outside on a clear August night and watch the Perseids crossing the sky, those brief, bright lines that appear and vanish in a second, the ones that make people reach for someone's arm or whisper something involuntarily, what you are actually watching is your atmosphere doing its job. Those fragments, most of them no larger than a grain of sand, are entering the upper reaches of the air column at tens of thousands of miles per hour. And the friction of 60 miles of compressed gas is converting their velocity into light before they can reach the ground. The streak you see is not the rock. The streak is the rock dying. And the atmosphere does this continuously around the entire planet, every hour of every day, for every piece of debris that crosses Earth's path. The total mass of material that enters the atmosphere daily has been calculated at roughly 48 tons. A fully loaded freight truck, the kind you see on the highway hauling goods between cities, weighs about 40 tons at maximum capacity. The Earth is absorbing the equivalent of more than one of those, in stone and metal, every single day, silently, invisibly, without any of us ever noticing. Because by the time any of it could reach a roof or a field or a person's head, it has already been converted into light and gas 60 miles above us. That is the scale of protection the atmosphere provides without ever being asked. And the moon has none of it. Not a thin version. Not a partial substitute. The moon's surface is exposed directly to open space, with no intervening layer of any substance capable of slowing an incoming object by so much as a single mile per hour. When a grain of sand, the same grain of sand that would have burned to nothing 100,000 feet above your head, crosses the moon's path, it hits the regolith at whatever speed it was traveling through the solar system. No friction, no resistance, no warning, and no negotiation. The grain arrives and the grain strikes, and the energy has nowhere to go except into the ground, which is why even a fragment small enough to hold between your fingers can produce a measurable crater and a flash of heat above the melting point of steel. And then there is the larger question, the one that the probability tables make impossible to ignore, which is that NASA is planning to send people there, not to fly past, as the crew of Integrity did, but to land. Artemis 3 will place astronauts directly on the lunar surface. Artemis 4 will establish a crewed orbital station above the moon, a structure that human beings will live and work inside for extended periods. These are not speculative proposals sitting in a planning document somewhere. They are the scheduled next steps of an active program, funded and in preparation, following directly from the mission that recorded 6 impact flashes during a single 7-hour pass. The probability mathematics for structures in the lunar environment have been worked out by the people responsible for keeping those structures intact. A small outpost, something under 400 square meters of surface area, carries a probability of roughly 29 in 100,000 of being struck by a meteoroid in a decade. That sounds manageable until you remember what the striking object does. A meteoroid weighing 5 kilograms, roughly the weight of a standard bag of flour, the kind sitting in a kitchen cabinet, something you could lift with one hand, traveling at the average impact velocity would excavate a crater approximately 30 feet across upon striking the lunar surface. 30 feet. A crater you could park several cars inside, opened in the ground in a fraction of a second, by something that weighs less than most house cats weigh when fully grown. Now, consider that the probability scales directly with the size of the structure being protected. An 8,000 square meter complex, something comparable in footprint to a reasonably sized research station, carries a worst-case strike probability of 0.9% over a decade. And an ISS-sized structure in lunar orbit, something comparable in scale to the station that has housed continuous human presence in low Earth orbit since 2000, carries a 1 to 2% probability of impact over 5 or more years of operation. 1 to 2% does not sound catastrophic until you remember that the International Space Station currently operates inside Earth's magnetosphere, with some residual atmospheric drag, and that even there the station requires periodic debris avoidance maneuvers. In lunar orbit, there is no magnetosphere offering protection, no atmospheric drag gradually pulling debris into harmless decay, and no ground-based radar network tracking the objects small enough to be the most dangerous. because the objects that produce impact flashes are, by definition, too small to track before they arrive. And then there is the spacesuit. The standard assumption, the comfortable assumption that most people carry without ever examining it directly, is that an astronaut in a pressure suit standing on the surface of another world is protected by that suit, that the layers of material between their skin and the vacuum constitute a meaningful defense. The suit is engineered to maintain pressure, to regulate temperature, to filter radiation across a range of wavelengths. No spacesuit currently in existence is capable of stopping a micrometeorite traveling at orbital velocity. The energy involved is simply beyond what any wearable material can absorb. The suit that will be worn by the Artemis 3 crew on the surface of the moon will protect them from the cold and the vacuum and the radiation, and it will not protect them from the bombardment that the moon has been absorbing, at 7.4 impacts per hour, since before the Earth's oceans formed. And we have not even left the surface yet. The impact flashes tell us the moon is dangerous. But when the crew looked out the window at the far side, they saw something that told them the moon is also strange. The far side does not look like the near side. It does not look like any photograph the crew had studied. What the crew saw when they crossed to the far side was not what any of them had prepared themselves to see. They had studied the photographs. They had reviewed the orbital maps. They had spent years training on the geology and the topography, and none of that preparation fully accounted for the experience of looking out a window at a world that did not match the one they had memorized. The far side of the moon is brighter, not in the way a freshly painted wall is brighter than an old one, but in a more fundamental way, structurally brighter, textured differently, wrong in a way that takes a moment to name. The dark plains that define the near side, the broad, smooth basins that you can see from your backyard on a clear night, and have probably looked at dozens of times without thinking about them, are almost entirely absent on the far side. Those dark plains have a name. They are called Maria, from the Latin word for seas, because early astronomers looked up and thought they were looking at water. They are not water. They are ancient frozen lava, vast pools of basalt that erupted from the lunar interior billions of years ago, and spread across the surface and cooled into smooth, dark rock. And they cover 31% of the near side. 31%. Roughly a third of everything you see when you look at the moon from Earth is lava that flooded out of the interior and hardened in place. The far side has less than 1% of that coverage. Less than 1%. This is worth pausing on. The moon you see from your backyard is not the moon. It is half the moon. The other half is a stranger. Imagine looking at a human face where one side is smooth and dark and sculpted into broad open plains, and the other side is rough and pale and shattered into overlapping craters with no flat ground anywhere, as though two completely different sculptors worked on the same head using completely different materials and completely different intentions. The near side looks like a world that was finished. The far side looks like a world that was abandoned halfway through, and the difference is not subtle. It is not a matter of degree. The two hemispheres of the moon are geologically alien to each other in a way that has no real equivalent anywhere in the terrestrial experience. Part of the explanation is structural. The crust on the far side is thicker, up to 20 kilometers thicker than the crust on the near side. 20 kilometers. That is roughly 12 miles of additional rock layered between the surface and the mantle beneath it. To make that tangible, a commercial airliner cruises at approximately 6 to 7 miles above the ground. The far side's extra crust is the equivalent of stacking that cruising altitude on top of itself nearly twice and then burying it underground. 12 miles of additional rock, cold and dense and unyielding, sitting between the surface and whatever heat the interior might have been trying to express. When the lunar interior generated heat, when the mantle began to produce magma that wanted to rise, that extra thickness on the far side was enough to stop it. The lava that reached the surface on the near side and spread into the Maria never made it through the crust on the far side. It stalled. It cooled underground. The surface stayed untouched, pale, cratered, preserved from an era 4 billion years ago when the moon was still being assembled by collision. But the thickness alone does not explain everything, because the thickness itself needs an explanation. And that explanation reaches into the chemistry of the moon's interior in a way that makes the two hemispheres feel not just Structurally different, but constitutionally different, as though they were made from slightly different recipes. Concentrated on the near side, buried beneath the basaltic plains, is a region of the lunar crust and upper mantle that scientists call the Procellarum Creep terrain. CREEP is an acronym built from the names of the elements it contains: potassium, rare earth elements, and phosphorus. But the elements that matter most for understanding what happened to the two faces of the moon are the ones embedded in that terrain alongside the potassium and the phosphorus: uranium and thorium. Both of them radioactive, both of them generating heat as they decay. And on the near side, they're concentrated in a buried region roughly the size of a continent, a deep thermal anomaly sitting under roughly 1/3 of the moon's hemisphere, releasing heat across timescales that are difficult to hold in the mind. For billions of years, not millions, billions. This buried furnace on the near side kept the mantle beneath it warm enough to generate the volcanic eruptions that produced the Maria, warm enough to keep the interior mobile, while the far side, with no equivalent concentration of heat-producing elements, cooled and stiffened and locked itself in place. A 2025 study by Park and colleagues, using tidal response data, measurements of how the moon flexes slightly in response to Earth's gravity, confirmed that the near side mantle is measurably warmer than the far side mantle even today. Not by ancient inference, by direct measurement. The asymmetry is not a relic of the past that has since been erased. It is present and ongoing. So the two sides of the moon are not just visually different, they are chemically different, thermally different, structurally different in ways that trace back to a single asymmetric distribution of radioactive elements that formed early in the moon's history, concentrated on one hemisphere, and then spent the next 4 billion years driving everything that followed. One side got the furnace, the other side got nothing. And when you hold that image in your mind alongside what the crew saw from the Orion capsule, the pale, shattered, uninterrupted terrain of the far side stretching out beneath them with no dark plains anywhere, no smooth lava sheets, just crater after crater after crater going all the way to the horizon, the difference stops being a scientific abstraction and starts feeling like the visible record of a lottery. A chemical coin flip that happened before life existed anywhere in this solar system decided permanently which side of the moon would stay alive and which side would go cold. And the question that follows from that, the question the crew could not have avoided asking as they looked out at that alien terrain, is how that coin flip happened in the first place. How does one hemisphere of a world end up with a nuclear furnace buried inside it, and the other end up with nothing? The answer traces back to the most violent event in the moon's history, the event that created it. The event that created the moon was not a collision in any sense the word usually carries. When you hear the word collision, you think of two things meeting and bouncing apart, or crumpling against each other, or breaking into pieces that scatter and settle. You think of something that happens quickly and leaves wreckage. What happened 4.5 billion years ago was something different in kind. Not just in scale. A body roughly the size of Mars, not an asteroid, not a comet, not a fragment of debris, but an entire planet with its own geology and its own gravitational history, struck the early Earth at an angle and at a velocity that turned both objects into something that had not existed before and would not exist again. Scientists call this body Theia, and a paper published in November of 2025 in the journal Science, led by Hopp and colleagues, traced Theia's likely origin to the inner solar system, placing it among the same population of rocky bodies that eventually became Mercury and Venus and Earth itself. Theia was not a visitor from the outer system, it was a neighbor, and 4.5 billion years ago, it ended. The collision produced a disk of vaporized and molten material that eventually coalesced into the moon, and for a period afterward, a period measured in millions of years, the moon's entire surface was a global ocean of magma, not patches of lava, not volcanically active regions. The entire body, down to considerable depth, was liquid rock, and it is in this magma ocean phase that the asymmetry begins, because as that ocean slowly cooled and crystallized, the radioactive elements, the uranium, the thorium, the potassium, did not distribute themselves evenly. they concentrated. And the mechanism that concentrated them on one hemisphere rather than the other was the gravitational relationship between the young moon and the young Earth. The tidal interaction between the two bodies as the moon solidified appears to have driven the incompatible elements, the ones that do not easily fit into the crystal structures of solidifying rock, toward one hemisphere, a physical process governed by gravity and chemistry, with a result that was essentially a coin flip determined before life existed anywhere on this planet. One side accumulated the furnace, the other side got none of it, cooled evenly, stiffened early, and has remained geologically inert for most of the moon's history. Sit with the randomness of that for a moment. Not a design, not a gradient that naturally favored one side. A physical process that could, under slightly different initial conditions, have concentrated those elements on the other hemisphere entirely, or distributed them more evenly, or produced a moon with no Maria at all. The two faces of the moon, with all the consequences that flow from them, the volcanism, the terrain differences, the chemical composition, the resources that will or will not be available to people who try to live there, trace back to a contingent outcome during the first few 100 million years of the solar system's existence. The Chang'e 6 mission, which landed in the South Pole Aitken Basin on the far side of the moon in June of 2024, returned the first samples ever collected from that hemisphere. The results were published in Nature in July of 2025 across 4 separate papers, and a September 2025 study in Nature Geoscience examined what those samples revealed about the far side's volcanic history. The lavas that formed the far side's ancient terrain crystallized at around 1,100 degrees Celsius, roughly 100 degrees cooler than the temperatures at which near-side lavas formed. 100 degrees may not sound like much in conversation, but in the context of magma, it is an enormous difference. It means the far side mantle was generating less heat, sustaining less vigorous volcanic activity, producing thinner and less extensive lava flows before shutting down entirely. The far side did not just cool faster, it was running on a fundamentally weaker engine from the beginning, and the Chang'e 6 samples are the physical confirmation of that, brought back in a sample container and measured in a laboratory, no longer inferred, but held. And then there is the water. The same samples measured water content in the far side rock at less than 2 micrograms per gram. If you took a full kilogram of far side lunar material, a rock you could lift with one hand, roughly the weight of a large water bottle, and extracted every molecule of water bound within it, you would not collect enough liquid to wet the tip of your finger. Less than 2 micrograms per gram is not a measurement of dryness as a relative condition. It is a measurement of dryness as an absolute one. Compare that to near-side samples, which carry up to 200 micrograms of water per gram of rock. The difference is not marginal, it is a factor of roughly 100. The near side is not just wetter than the far side in the way that one desert is wetter than another desert. It is a different world in terms of what it contains and what it could support. The far side, as a resource environment, is not depleted or scarce. It is essentially empty of the single most critical substance for any long-duration human presence anywhere beyond Earth. Water is not a comfort on a lunar base, it is life support, fuel production through electrolysis, radiation shielding in the walls, agriculture if agriculture is ever attempted. Every litre that cannot be sourced locally has to be lifted from Earth's surface against its gravity well at a cost that makes the mission economics of any permanent far side installation almost impossible to close. The far side is bone dry. That is not a metaphor for difficulty. That is the measurement. The answer to where water might exist on the moon at all is at the bottom of the moon. In craters so deep that sunlight has not reached their floors in billions of years. Those craters exist at the lunar South Pole, and they are unlike anything else on the moon or on any world that humans have yet visited. The geometry of the South Pole is what makes them possible. The moon's axial tilt is very slight, just 1.5 degrees, which means the sun never rises high above the horizon near the poles. At certain latitudes, the crater rims are tall enough to permanently block the sun from ever reaching the crater floors below. And when the sun does not reach you on the moon, it does not reach you for a very long time. Some of these crater floors have not received direct sunlight in 2 billion years. Others have not seen sunlight since the solar system was still forming around them. The result is a cold so extreme that it almost requires different language to describe. The floors of permanently shadowed craters at the lunar South Pole drop to below negative 230 degrees Celsius. To give that number a physical reference, liquid nitrogen, which most people associate with extreme cold, sits at around negative 196 degrees Celsius. The floors of these craters are colder than that. They are, in fact, among the coldest naturally occurring places in the entire solar system. Colder than the surface of Pluto during certain parts of its orbit. Colder than the empty space between many nearby stars. In temperatures that low, water molecules that drift into the crater do not sublimate back into gas and drift away. They freeze to the surface and stay there. They have been staying there, slowly accumulating for potentially billions of years, delivered by comets and asteroids that struck the moon and released their volatile contents, with some fraction of that water eventually finding its way into the permanent shadow and locking in place. India's Chandrayaan-1 mission detected signatures consistent with water ice at the lunar poles as far back as 2008, and the Lunar Reconnaissance Orbiter, which NASA placed in orbit in 2009, has been mapping the South Pole's terrain in detail ever since, building a picture of where the shadowed regions are, how cold they run, and where the ice signatures are strongest. That mapping is part of what drove the decision to target the South Pole for Artemis 3, which will be the first crewed lunar landing since Apollo 17 in 1972. The South Pole is not just a scientifically compelling location. It is where the water might be, and if humans are going to remain on the moon for any extended period, they need to go where the water might be. But the honest answer is that no one yet knows whether there is enough water at the lunar poles to sustain a permanent human presence. The ice may be mixed with regolith in concentrations too low to extract economically or at all. It may exist only in isolated pockets rather than in the continuous deposits that would make extraction practical. It may not be there in the quantities the orbital signatures suggest. The detection of water ice signatures is not the same as finding a cistern. It is finding a trace. And the gap between a trace and a supply line is exactly the kind of gap that has ended missions before they started. And that gap is the next problem waiting on the far side of the South Pole question. And we have not even left the surface yet. While the mission planners were working through those numbers, crater depths, extraction rates, minimum viable water concentrations, Kelsey Young, who served as Artemis II's lunar science lead, was focused on something that no orbital instrument had been able to provide. The crew aboard Orion had 10 formal science objectives during the flyby, and one of them involved something as apparently simple as looking at color. But on the moon, color is not simple. Cameras, whether they are mounted on the Lunar Reconnaissance Orbiter or on any other satellite, capture reflected light in fixed wavelength bands. The sensor is tuned to specific frequencies, and it records those frequencies with precision. What it cannot do is perceive the continuous spectrum that sits between those bands. It is something like playing a piano where half the keys have been removed. You can reconstruct the shape of the melody, but you are missing every note that falls in between. The human eye does not work that way. It perceives color as a continuous gradient, reading the full spectrum without gaps, integrating shifts in tone and hue that no fixed band sensor can replicate. What the crew saw when they looked at the lunar surface from 4,000 miles out, and then closer still, was a range of browns and blues and greens that no satellite image had ever captured. Young described the challenge of training human observers for that experience by using an analogy involving sand. If you change the angle at which light falls on a patch of sand, you shift between perceiving its color and albedo on one hand, and its texture and topography on the other. The crew, because their viewing angle was continuously changing as Orion moved through the flyby, were seeing both simultaneously and in constant transition. Not the frozen snapshot of a single orbital pass, but a flowing, unbroken read of the surface's full visual character. The browns were warmer than any photograph suggested. The blues appeared along the edges of certain highland regions where no spectral survey had noted them. The greens were faint but real, perceptible to 4 sets of human eyes and entirely absent from every archived image. Robots collect data. Humans, it turns out, collect something else entirely. But the most dramatic thing the crew saw during the flyby was not a color at all. It was a line. A line. And to understand what that line was, and why seeing it from inside a spacecraft window produced the specific quality of disorientation that the crew described, you have to understand what happens to the moon's surface when sunlight arrives not from above but from almost exactly sideways. The terminator is the word for it, the boundary where sunlight ends and shadow begins on the lunar surface. From a satellite orbiting overhead, looking almost straight down, the terminator appears as a gradual fade, a soft transition between the lit hemisphere and the dark one. But from a position beside the moon rather than above it, the terminator is something else entirely. It is where the geometry of light turns ruthless. At that angle, the sun is essentially skimming the surface, arriving at perhaps 1 or 2 degrees above the horizon, rather than 60 or 70. And at 1 or 2 degrees, the light does not illuminate the landscape. It interrogates it. Every ridge that protrudes a few meters above the plane casts a shadow hundreds of meters long. Every shallow depression that an overhead camera would read as essentially flat becomes a visible well of darkness. Collapsed lava tubes, long roofless channels where ancient volcanic flows once moved beneath the surface and then drained away, leaving hollow corridors that later caved in, are invisible from above because they are only a few meters deep relative to their width. Under raking light, they become unmistakable trenches, throwing shadows that announce their shape with a clarity no orbital map had ever captured. Micro ridges that appear in no geological survey because they are too small and too shallow to register against the noise of overhead imaging suddenly stand out as sharp, continuous features running for kilometers across the surface. The entire landscape reorganizes itself under that geometry. Victor Glover described what he saw as islands of terrain completely surrounded by darkness. The phrase is exact. What he was seeing was the tops of slight rises. Rises so gentle that from above they would be classified as essentially level ground, catching the last degree of sunlight, while everything between them lay in the long shadow of that low angle. The terrain was not actually divided into islands. It only appeared that way because the light was arriving at an angle so shallow that only the highest points of what was effectively flat ground could still catch it. The rest had already crossed into shadow, and so the eye perceived a fragmented, archipelago-like surface, bright patches of rock floating in black, with no visible connections between them, as though the ground itself had been broken apart and scattered. That is the moon as it actually looks when the light is working correctly. The smooth, grey, undifferentiated sphere of every orbital photograph is an artifact of the geometry of satellites looking straight down. The billiard ball illusion is real. A billiard ball seen from 3 feet away under overhead light looks smooth and featureless. Bring a torch down to table level and aim it across the ball at a grazing angle, and every microscopic scratch and chip in the surface casts its own tiny shadow. The ball is the same. The light is different. The moon's surface, under grazing illumination, is a billiard ball with the torch at table level, and what the crew was seeing was every scratch and chip and hollow that 4.5 billion years of bombardment had written into it. Glover also reported something that stopped him for a moment, something his training had to override before he could process it correctly. The mountain peaks near the Terminator appeared white, not light grey, not pale, white, with the specific, almost luminous quality of fresh snow catching sunlight at a low angle on a clear winter morning. His brain read it as snow before the rest of his knowledge caught up. What he was actually seeing was unweathered rock so freshly exposed by a geologically recent impact that it had not yet had time to undergo the darkening process that erodes lunar surfaces over millions of years. Fresh lunar rock, before the solar wind and micrometeorite bombardment have had centuries to work on it, has an albedo, a reflectivity, that is genuinely comparable to snow. And when that rock sits on the crest of an elevation, at the precise moment the sun is at 1 or 2 degrees above the horizon, the reflection is nearly direct. The light comes in nearly parallel to the surface, and the peak is the only thing tilted toward it. And the result is a brightness so unexpected against the surrounding darkness that 4 astronauts, all of them trained geologists and scientists, all of them prepared for what the moon looks like, had to consciously correct their initial perception. Nichelle Koch described the young craters differently. She described them as a lampshade with tiny pinprick holes and a light shining through from behind. The young craters, still bright, because they too had not yet darkened with age, were sitting on the shadowed side of the Terminator when she saw them. They were in the dark portion of the boundary, but they were bright enough, and the surrounding surface dark enough that they appeared to glow rather than reflect. Small circles of pale light in a black field, like the way light escapes through imperfections in a lampshade rather than through its open end. The analogy is not decorative. It captures something precise about the perception. These craters were not bright objects in a lit landscape. They were bright objects in a dark one, and that reversal transformed how they registered to the eye. To prepare for these observations, the crew had worked in pairs during the flyby, rotating through shifts that ran between 55 and 85 minutes, long enough for the eyes to dark adapt and the brain to settle into careful looking, short enough to maintain the quality of attention the work required. About 35 specific geological features had been preloaded into portable software built for the mission, giving the crew reference targets to watch for as Orion moved through the flyby geometry. One of the windows was covered with a t-shirt to reduce internal light and prevent the interior of the cabin from washing out the view. A condensation hose was required to manage the moisture their breath produced in the cold near the window. The conditions were improvised, constrained, deeply human. 4 people pressing their faces toward cold glass in a capsule hundreds of thousands of miles from home, sweating and breathing condensation while they tried to document what had never been documented before. And what they saw was a landscape that no satellite and no prior human crew had ever been positioned to observe. Because the impact flashes on the surface were not the only mysterious lights the astronauts encountered near the moon. There were others, inside their own eyes, behind their closed eyelids, in total darkness. And then Orion came back around. At 7:24 in the evening Eastern Time on April 6th, 2026, the signal returned, first to carrier wave, then data, then voice, and 4 astronauts who had spent 40 minutes in complete isolation behind a world were suddenly in contact with the rest of humanity again. The blackout ended the way blackouts always end, abruptly, without ceremony, as if the silence had simply run out of room. But what the crew reported seeing in those first moments of restored contact was not what mission controllers had been expecting to hear about. Before they talked about the impact flashes, before they talked about the geological features they had documented, before they talked about the Terminator or the lampshade craters or the raking light across the ridgelines, they talked about the Earth. When Orion cleared the lunar limb and the crew looked through those windows toward open space, what they saw rising above the horizon of the moon was the Earth. Blue, white, impossibly fragile, suspended against a blackness so complete it had no texture and no depth, hanging there like something someone had placed carefully rather than something that had arrived through 4.5 billion years of orbital mechanics. It is worth saying plainly that this was not a surprise in any logistical sense. The crew knew the Earth would be visible. The geometry of the flyby made that inevitable. What was a surprise was the effect. Nichelle Koch, when she was later asked to describe what she felt in that moment, gave an answer that takes longer to sit with than it does to read. She said one word: humility. Not wonder, not awe, not beauty, though it was certainly beautiful. Humility. As if the thing the Earth communicated, at that distance and in that context, was not its grandeur, but its vulnerability. And not the planet's vulnerability, but the crew's own, and everyone aboard it. Frank White wrote about this in 1987, when he coined the phrase the overview effect, to describe what astronauts consistently reported experiencing when they saw the Earth from space for the first time. Not euphoria, though there was euphoria. Not pride, though there was that too. What White identified was something closer to a recalibration, a permanent shift in the way a person understood the relationship between the planet and everything they had ever cared about on it. The arguments, the borders, the accumulated grievances of history, all of it visible from orbit as a single, unified, completely indivisible object, with a paper-thin shell of atmosphere that, from the distance Orion had traveled, you could cover with your thumb. This is not a metaphor. from 252,000 miles away. The atmosphere of Earth, the entire volume of air that has sustained every living thing in the history of this planet, is thinner, relative to the globe, than the skin of an apple. The crew of Orion Integrity was not the first to see this, but each person who sees it for the first time, and the effect does not diminish with repetition because it is not a thought. It is a perception. It rewires something. The first photograph of this image, the Earth rising above the lunar surface, was taken on December 24th, 1968, by Bill Anders aboard Apollo 8. Frank Borman and Jim Lovell were both on that mission. The photograph Anders took has been called the most influential environmental photograph ever taken, a designation offered by the photographer and writer Galen Ruhl, and one that is difficult to argue against when you consider what it communicated, that the planet was one thing, whole and bounded and fragile, in a universe that had no apparent interest in its survival. An Apollo 8 silk patch flew aboard Orion Integrity on the April 2026 flyby, a thread of continuity between the first humans to see the Earth rise over the moon and the crew now watching it rise again, carrying with them the artifact of the people who first understood what they were looking at. Jim Lovell was on Apollo 8. He was also the commander of Apollo 13, the mission whose distance record the Artemis II crew had just broken by 4,111 miles. He was 97 years old when he recorded a wake-up message for the Orion Integrity crew, 2 months before he died, in August of 2025. In the recording, his voice carried the particular quality that very old voices sometimes carry: a lightness, a patience, the sound of a person who has already decided what matters. The message he left them was simple: do not forget to enjoy the view. He said it the way you say something you mean, with your whole history behind it. Not as advice, but as a transmission. From a man who had seen the Earth from a distance that, at the time, no human being had ever survived to describe. To 4 people who were about to go further: do not forget to enjoy the view. He died before the mission flew. The crew carried his voice with them anyway. And then, somewhere in the hours that followed the blackout, Jeremy Hansen did something that had not been on any mission timeline. That was not a science objective. That would not appear in any technical report, but that may be the clearest argument for sending human beings into space that this mission produced. He named 2 craters. The first he named Integrity, after the spacecraft, located northwest of the Oriental Basin, on the near side of the moon. The second he named Carol, and he named it for a woman he had never met, for Reed Wiseman's wife. Carol Taylor Wiseman had been a neonatal intensive care nurse at Children's Hospital of the King's Daughters in Norfolk, Virginia. She had been a school nurse in Maryland and in Texas. She had been born in Virginia Beach, had graduated from Virginia Commonwealth University, had raised 2 daughters named Katie and Ellie. She had died of cancer in 2020 in a way that left people behind with the particular, irreducible weight of a life that ended at 46. The crater Hansen chose for her name sits on the boundary between the near and far sides of the moon, near Glushko crater, at the edge of the world that faces Earth, and the world that faces away. The names are to be submitted to the International Astronomical Union for formal designation. When Hansen told the crew what he had done, the 4 of them, 250,000 miles from home, weightless, in a capsule the size of a large living room, embraced, not one at a time. All 4 of them, together, floating, a group of people holding onto each other in microgravity while mission control, on the other end of the radio link, went silent. The silence on that channel was not a technical event. It was people who had spent years on this mission understanding, without needing to say it, what they were witnessing. A crater on the boundary of the far side of the moon will carry the name of a neonatal nurse from Virginia Beach who died at 46 and never had the chance to watch her daughters grow old. Her husband had gone further from Earth than any human being in recorded history, and someone thought to bring her name along. There is no instrument that measures this. There is no satellite that returns this kind of data. Robots collect measurements. Humans collect something that does not have a category in any mission report: the capacity to grieve and name and hold onto each other 250,000 miles from everything, and to mean it completely. That is not a secondary benefit of human spaceflight. That is the argument. distilled into a single act, a floating embrace, a name on a crater at the edge of the world no human being had ever looked at until now. And while the crew was still processing what had just happened, still weeping, still holding on, Victor Glover had pressed his face back against the window. Because on the surface below, something was pulling his attention away from the grief and toward the ground. Something he was seeing that he had not expected to see. Victor Glover had seen something through the window, something that pulled him away from the grief and back toward the surface, and the answer to what he was looking at belongs to the same story. But the answer to what the crew was experiencing inside the capsule, what every Apollo astronaut experienced, and what the Artemis crew almost certainly experienced as well, though no one has said so publicly yet, that answer requires going somewhere none of the mission reports fully prepare you for. It requires understanding what the spacecraft does not stop, what no spacecraft stops, what passes through the hull and through the seat foam, and through the pressure suits, and through the skin and muscle and bone of the people sitting inside, the whole time, without making a sound. The answer came from studying the men who went before them. Buzz Aldrin reported it first, after Apollo 11 in 1969. He described seeing flashes of light, brief, unprompted, appearing behind his closed eyes in the darkness of the lunar module during rest periods. Not dreamlike, not the slow drifting imagery of someone falling asleep. These were discrete events, sudden, geometric in some cases, appearing and then gone, with no obvious cause and no warning. Other crew members reported the same thing. The phenomenon had 3 distinct forms. Some astronauts saw simple spots, like someone had momentarily pressed a thumb against a switched-off television screen. Others saw what they described as stars, a single point of brief brightness. And others, Edgar Mitchell on Apollo 14 among them, described streaks, lines of light moving across the visual field, sometimes with a blue tint and a white cast to them, like something had dragged a luminous wire briefly across the inside of the eye. Mitchell was precise about the color. Blue with white, and that specificity turns out to be important. The average rate at which these events occurred, once researchers began studying them carefully, came out to 1 flash every 2.9 minutes. That number is easy to absorb as a statistic, and almost impossible to absorb as an experience. So consider what it actually means to sit inside it. Close your eyes for a moment, and count to 174. In the silence of that count, if you were floating in a spacecraft at lunar distance, a particle moving at nearly the speed of light would have passed through your skull, through the capsule wall, through the vitreous humor of one of your eyes, or through the neurons of your visual cortex, or directly through the tissue of your optic nerve, and then out the other side and on into space, and you would have seen a flash you could not explain and could not prevent. And then you would count to 174 again, and it would happen again. And we have not even left the surface yet, because we are still talking about crews who spent days in transit. The astronauts who will live and work in lunar orbit for weeks, or who will one day travel to Mars for years, will not be counting to 174 between flashes. They will simply live inside a continuous, quiet bombardment. The phenomenon has a name and it has a mechanism, and both of them are stranger than the description alone suggests. What those astronauts were seeing was Cherenkov radiation, when a charged particle, a cosmic ray moving through the vitreous humor of the eye, moves faster than light can travel through that particular medium. It generates a brief emission of photons. Not an explosion, not heat in any conventional sense, just light, produced by the same physics that causes the unmistakable blue glow you see in photographs of the water surrounding nuclear reactor cores. The pale, cold, slightly ethereal blue that photographers always mention when they describe standing near an active reactor pool. That is Cherenkov radiation. The water around the core is transparent, and particles passing through it exceed the local speed of light in that medium, and the result is a continuous, soft luminescence. The astronaut's eye is not a reactor pool, and the particles are not streaming from a controlled fission source, but the underlying mechanism is identical. What Mitchell saw in the darkness of the lunar module, blue with white cast, a streak rather than a point, was almost certainly a relativistic particle producing Cherenkov light as it transited the fluid of his eye. He was watching himself being irradiated, not metaphorically, literally watching the particle damage occur in real time, in the only way the biology of the eye happens to make visible. NASA fitted Apollo 16 and Apollo 17 with a device called the Apollo Light Flash Moving Emulsion Detector, essentially a nuclear particle detector designed to track cosmic ray paths at the same time the crew members reported visual events. The hope was to correlate the particle tracks with the flash reports to confirm the mechanism directly. The results were partial. Of 15 particle tracks recorded, 2 coincided with flash reports from the crew, 2 out of 15. That is not a confident confirmation, and the researchers at the time said so. The honest answer is that the mechanism remains somewhat uncertain even now. Cherenkov radiation in the vitreous humor is the leading explanation, but direct ionization of the retina itself and stimulation of the visual cortex or optic nerve by passing particles are also considered plausible, and some flashes may involve more than one pathway simultaneously. What increased the rate of flashes, however, was less ambiguous. Astronauts aboard the International Space Station, when passing over the South Atlantic Anomaly, a region where the Van Allen belts dip unusually close to Earth's surface, concentrating trapped radiation, consistently reported higher flash frequencies. Jerry Lininger, during his time aboard the Russian station Mir in 1997, reported something more specific still: flashes that appeared to have a direction. During solar particle events, when the sun had thrown a burst of charged particles toward Earth, Lininger noticed that the flashes seemed to be coming from one side of his visual field rather than appearing uniformly. He was, in some sense, detecting the direction of the solar wind with his own retina, not because the eye is a radiation detector. It is not built for this, but because the exposure was heavy enough that the effect had a spatial signature. The flashes were not evenly distributed. They were coming from somewhere. That is not a curiosity. It is a symptom. The flashes are the one thing about cosmic ray exposure that the human body makes visible, and they are only made visible because the eye happens to produce photons in response to ionizing particles in a way that the visual system interprets as light. The rest of the damage, the ionization events in skin cells, in lung tissue, in bone marrow, in the DNA of actively dividing cells, produces no signal the conscious mind can detect. There is no sensation, no heat, no pressure, no warning. The cosmic rays that produce those flashes are the same particles doing the invisible work throughout the body, and the only reason the eye reports them is an accident of anatomy, which means every flash the astronaut sees is a reminder that the damage they cannot see is also continuously occurring. And that invisible damage is the part that a published analysis in the journal Science in January of 2026 tried to quantify more precisely, because for 50 years, the medical data had been sitting there, waiting for a large enough sample and a long enough follow-up period to say something definitive. The sample remains heartbreakingly small. 24 human beings have ever traveled beyond Earth's magnetic field. 24. All of them flew on Apollo missions. All of them were men. And only now, with Artemis II, has the category expanded. Christina Koch becoming the first woman, Victor Glover, the first black astronaut, and Jeremy Hansen, the first person from outside the United States to travel beyond low Earth orbit. For half a century, the entire dataset of deep space human exposure consisted of those 24 individuals, which is a smaller group than the number of people who summit Mount Everest on a single busy day in May. You can fit every human being who has ever flown beyond the protection of Earth's magnetic field into a modest conference room and still have empty chairs. That is the entire foundation on which deep space medicine is built. And yet, even that sample produced a signal. Apollo astronauts showed significantly elevated rates of cardiovascular disease compared to astronauts who flew only in low Earth orbit, where the Van Allen belts still provide partial shielding. The difference was not trivial. The Apollo crews had cardiovascular mortality rates roughly 4 to 5 times higher than their low orbit counterparts. That comparison is not perfect. The populations were small, the missions varied, other factors existed, and researchers have said clearly that certainty requires more data. But the direction of the signal is consistent with what particle physics would predict. Cosmic rays do not merely pass through the body like light passes through glass. They interact. They break molecular bonds. They damage DNA directly, snapping both strands of the double helix in ways that the cell's repair mechanisms sometimes cannot correctly reconstruct. They cause mutations. They promote the kind of cellular environment in which cardiovascular tissue ages faster than it should, in which the lining of blood vessels accumulates damage that looks, under a microscope, like decades of ordinary aging compressed into days. Mouse studies extended the picture further. Rodents exposed to simulated cosmic ray bombardment showed measurable cognitive decline. Not immediately, but over time, as the accumulated damage worked through the neural tissue, memory, decision-making, the kind of higher-order function that depends on the integrity of neural connections that cosmic rays are particularly good at disrupting. The mice were not incapacitated. They were diminished. And the researchers working with those results were careful to say that rodent neurology and human neurology are not identical, that the translation is uncertain, but the mechanism is not uncertain. The particles are real, the ionization is real, the bond breaking is real. The Artemis II mission lasted 10 days. The crew's bodies absorbed cosmic ray bombardment for 10 days. Every flash in their eyes, a visible reminder of the invisible work proceeding throughout every organ, every vessel, every strand of DNA in every cell. 10 days. A Mars mission would last 2 to 3 years. Not 10 days extended somewhat, not doubled or tripled, 2 to 3 years. Everything described here, every broken bond, every damaged vessel wall, every mutation introduced into a dividing cell, every flash of Cherenkov light dragging across the vitreous humor. Multiply it by 100. The Artemis II crew received their exposure and came home to Earth's magnetic field, to atmosphere, to the ordinary protection that every human being who has ever lived has taken entirely for granted. A Mars crew would spend somewhere between 700 and 1,000 days in the same environment the Apollo astronauts flew through for a week. The science does not yet know what that does to a human body, because no human body has ever experienced it. The answer will be written in the bodies of the people who go. And this is where the physics of cosmic radiation connects to something the crew was already looking at through the windows. Something that had puzzled scientists since the 1600s, and that seemed, at first glance, to have nothing to do with the radiation at all. As Orion flew across Oceanus Procellarum, the great dark plane on the western near side, the cameras were pointed at a feature visible from 4,000 miles up, a bright shape on the darker basalt below, a swirl that looks, in overhead imagery, something like a tadpole, or a comet, or a stroke of pale paint dragged across a darker canvas. It is called Rhina Gamma. Astronomers first noticed it through telescopes in the 1600s, and have been puzzling over it ever since, because the moon's surface is not supposed to look like that. The Maria are dark, the highlands are pale. The difference is understood. Iron-rich basalt on one side, and orthosite on the other. But Rhina Gamma sits on basalt and is bright anyway, and it is not a crater, and it has no obvious geological explanation in terms of what the surface is made of. What it sits on is one of the strongest localized magnetic anomalies on the entire lunar surface. The moon has no global magnetic field. It lost whatever dynamo it once possessed billions of years ago, and today, the lunar surface is almost entirely exposed to the solar wind and to cosmic rays, with no magnetic envelope to deflect them. But in isolated patches, ancient, remnant, geologically orphaned, there are regions where the rock itself is magnetized, where a field still exists, locally, pressed into the stone. And Rhina Gamma is one of the brightest and most visually dramatic of these patches, because wherever that local magnetic field persists, it deflects the solar wind particles that would otherwise darken the surface over time, and the result is a bright swirl preserved beneath a magnetic umbrella that should not, by any reasonable account, still be there. These patches are magnetic fossils. They are remnants of something the moon once had, and no longer has. The question of where they came from is still not settled. The question of where those magnetized patches came from is one that scientists have been debating for decades, and it is not settled yet. But the mechanism by which they produce the bright swirls, The way a remnant magnetic field on an otherwise unprotected surface can leave a visible mark. That part is better understood now. The process has a name that makes it sound almost protective, almost gentle. The magnetic sunscreen hypothesis. And what it describes is exactly that. Where a localized magnetic field persists in the lunar rock, it deflects the charged particles of the solar wind that would otherwise strike the surface and slowly darken it through a process called space weathering. The solar wind does not just pass through a surface harmlessly. Over millions of years, it alters the chemistry of the uppermost layer of rock, breaking molecular bonds, implanting ions, producing nanophase ion particles that gradually turn bright material darker. It is a slow, relentless darkening, and the entire lunar surface has been subjected to it for billions of years. But where a local magnetic field stands in the way, the solar wind curves around it, and the surface beneath stays brighter than it would otherwise be. In 2018, a study published in Communications Physics confirmed this model specifically for Rhina Gamma, showing that the geometry of the magnetic anomaly there is consistent with the geometry of the bright swirl above it, that the field is strong enough and shaped correctly to produce exactly the pattern of deflection that would leave the surface looking the way it does. But here is where it becomes more complicated and more revealing. Earth's magnetic field runs to roughly 50,000 nanotesla at the surface, a number that sounds abstract until you consider what it does. It wraps the entire planet in an invisible electromagnetic envelope, deflecting the solar wind across an area millions of times larger than any single continent, protecting every living thing on the surface from radiation that would otherwise be lethal. The magnetic anomalies on the moon are measured in the low hundreds of nanotesla, a few hundred at most. These patches are whispers compared to Earth's shout, and yet even that whisper is enough, locally, to nudge the solar wind away from the surface directly beneath it, and leave a bright patch that has persisted for hundreds of millions of years. The swirls are not made of different rock. They are not craters or volcanic deposits. They are the surface as it was, preserved beneath a magnetic umbrella that should not, by any reasonable accounting, still be there. And yet it is. That is what makes them so strange. They are a tattoo left behind by a field that no longer exists, a message written in magnetic ink by a process that scientists are still learning to read. And the origin of that magnetism is where the debate opens into genuine scientific uncertainty. There are three competing explanations, and the honest answer is that the evidence does not yet clearly favor one over the others. The first holds that the magnetization came from cometary impacts, that a comet, rich in volatile compounds and carrying its own weak magnetic field, struck the surface and deposited magnetized material that has remained ever since. The second explanation ties the anomalies to the basin-forming impacts of the early solar system, arguing that the tremendous heat and pressure of a major impact could have vaporized and reionized surrounding rock, and that as this plasma expanded and cooled, it interacted with the moon's then active global magnetic field to magnetize the material before it solidified. The third explanation, supported by a study published in the Journal of Geophysical Research Planets in 2024, points to high titanium magma crystallizing underground, specific geological processes beneath certain regions that could have produced magnetized formations from the inside out. Each explanation has evidence behind it. Each has problems. The reason the debate persists is not because scientists have not looked carefully enough, but because the moon's surface is old enough and complex enough that the same observable feature could plausibly have multiple causes in different locations. A mission called Lunar Vertex was designed specifically to land within Rhina Gamma and take surface measurements that could help resolve the question, though the mission has been rescheduled and the data has not yet come back. What a February 2026 study from Oxford did clarify is when the moon's global magnetic dynamo finally stopped operating. The answer is approximately 1 billion years ago. Though the dynamo did not simply switch off, it operated in multiple phases, strengthening and weakening over geological time before finally dying. 1 billion years is a number that the mind does not hold easily, but consider this: the Earth is roughly 4.5 billion years old. The moon's dynamo operated for 3.5 billion of those years, flickering and pulsing through its phases, and then went quiet. The swirls that remain are older than the extinction of the dinosaurs by a factor of hundreds. They are records from a time so deep that the oxygen in your lungs did not yet exist in the atmosphere. They are magnetic fossils, and they may hold the key to understanding not just the moon, but the entire early solar system. And from Reiner Gamma, if you let your eye travel across the western near side and down toward the limb, you begin to approach one of the most visually striking geological formations on the entire lunar surface, the Orientale Basin. It sits on the boundary between the near side and far side, and it is approximately 600 miles across, a diameter wider than the distance from Chicago to the Atlantic Ocean. It formed 3.8 billion years ago, and what makes it extraordinary is not just its age or its size, but its condition. Where other ancient basins have been softened and blurred by billions of years of subsequent impacts, Orientale is still sharply defined, still showing the concentric rings of mountain chains that its formation threw outward. They have names: the Cordillera Mountains on the outside, the Outer Rook Mountains inside that, and the Inner Rook Mountains inside those, each ring a frozen wave in rock, like the rings you see when you drop a stone into still water, except that the stone was an asteroid-scale impactor, and the water was the solid crust of the moon. And the rings have been frozen in place for 3.8 billion years. You are looking at a splash frozen mid-motion across geological time. Compare that to Hertzsprung, which sits further onto the far side and measures roughly 400 miles across. Hertzsprung is older, and its age shows in its appearance. The sharp features have been worn down by the slow accumulation of subsequent impacts. The rim is broken and degraded. The floor is cratered and recratered, until the original geometry is difficult to reconstruct. Orientale is a fresh scar. Hertzsprung is an old one. Same process, same moon, different ages. One still screams, one has faded to a whisper. And the distance in geological time between them gives you a sense of how long this surface has been accumulating its record of violence. Billions of years of impacts, each one recorded in stone that, with no water and no plate tectonics, has nowhere to go and nothing to erase it. The moon does not forget, but Orientale and Hertzsprung together, 600 miles, 400 miles, those are not even the largest structures in this record. There is something else on the far side that dwarfs them both. Something that makes Orientale look like a ripple in a puddle, and it sits almost exactly beneath the region where Orion would soon pass into total darkness. And what sits beneath that region, what actually defines the far side in geological terms more than any other single feature, is not a basin in the way that Orientale is a basin. It is something larger than the word basin was ever meant to contain. The South Pole Aitken Basin. Roughly 1,550 miles across and approximately 5 miles deep. And those two numbers, placed side by side, require some time to actually enter the mind rather than simply pass through it. 1,550 miles. Consider that the straight line distance from New York City to Denver, Colorado, across the full breadth of the American interior, across the Appalachians and the Mississippi River Valley and the Great Plains, is approximately 1,700 miles. The South Pole Aitken Basin is nearly that wide. If you placed one edge of it over the eastern seaboard, the other edge would land somewhere in the mountains of the American West. That is not a feature you could ever see as a whole from the ground. You would have to be in space, looking down, to comprehend it as a single object. And even then your eye would struggle to pass what it was looking at as one thing rather than an entire world. And the depth, 5 miles straight down from rim to floor, exceeds the deepest point in any ocean trench on Earth. The Mariana Trench, the deepest place on our own planet, descends to just under 7 miles at its lowest point. But the average floor of the Mariana Trench is shallower than that, and the South Pole Aitken Basin is 5 miles deep, across an area the width of a continent. You could sink the Rocky Mountains into it and lose them. You could pour in the entire volume of the Mediterranean Sea, and it would not fill. This is the scale we are talking about when we say the far side has a feature that makes Orientale look like a ripple in a puddle. The impactor that created this was something science does not like to think about for too long, because the energy required to excavate a hole 1,550 miles wide and 5 miles deep through the solid rock of a world is genuinely difficult to calculate without the numbers becoming strange. And the most extraordinary possibility, the one that geologists have been circling for decades, and that the Chang'e 6 mission may have helped confirm, is that the impactor did not just carve through crust. It may have punched all the way through the crust and into the mantle itself. That the rock sitting at the bottom of the South Pole Aitken Basin may not be crustal rock at all, but material from the moon's interior that was exposed and thrown outward during the collision, material that has not seen the surface since the moon was young. Chang'e 6, which landed in the basin in June of 2024 and returned samples to Earth, produced 4 papers published in Nature by July of 2025. And what those papers found in the rocks of the far side basin floor was a chemical signature that the near side simply does not share. The far side mantle, as revealed by those samples, is what the scientists described as extremely depleted in incompatible elements. The elements that, during the slow cooling of a molten world, tend to migrate toward the surface because they do not fit easily into the crystalline structures of solidifying rock. On the near side, those elements accumulated. The prosolarum creep terrain on the near side is essentially defined by their presence. On the far side, they are nearly absent, not depleted by a small margin, depleted to a degree that the two hemispheres at the deepest chemical level are not simply different landscapes on the same body. They are, in some meaningful sense, alien to each other. Two worlds that happen to share the same skin, each carrying a different record of how the moon was born and how it cooled and what it became. The South Pole Aitken Basin, by ripping open the far side crust, handed scientists a window into that difference that no amount of orbital observation could have provided. And the samples are still being analysed. The full story from those 4 papers is still being assembled. What Chang'e 6 brought back is not a conclusion. It is a question that will take years to finish asking. And it was somewhere over the edge of this basin, over this wound in the far side that stretches a continent and a half across, that the sun began to slip behind the moon. The eclipse entered totality at 8:35 in the evening, Eastern Time, on April 6th, 2026, and it lasted until 9:32, 57 minutes of totality. From Earth, a total solar eclipse typically lasts somewhere around 2 minutes at any given location, sometimes less, occasionally a little more if you're standing in exactly the right place under a narrow shadow moving at the speed of the moon's orbit. The crew of Orion experienced something 30 times longer, 57 unbroken minutes in which the sun was entirely behind the moon and the corona. The sun's outer atmosphere, which is invisible from Earth's surface under normal daylight, was fully revealed, wrapping around the dark silhouette of the moon in a crown of white streamers that reached outward in every direction. They wore eclipse glasses for the first 2 minutes as the sun's limb disappeared behind the lunar edge. The same simple filtered lenses you might buy for a few dollars at a hardware store before a terrestrial eclipse. And then totality arrived, and the glasses came off, and there was nothing to filter anymore because the direct disk of the sun was gone, and what replaced it was the corona. Victor Glover described it by reaching for the most powerful artificial light source he could think of. If you have ever seen the spotlight that rises from the top of the Luxor Hotel in Las Vegas, that column of white light that shoots straight up into the night sky and is visible from aircraft more than 200 miles away. One of the most powerful beams of concentrated light that human engineering has produced. Glover said this looks like what that wants to be when it grows up. Not what it reminds you of, what it aspires to be. The Luxor beam as an imitation of something it could never fully become. That comparison should settle into you for a moment. Because Glover is not a person who reaches for hyperbole easily. He is a naval aviator and a NASA astronaut, and a person trained to report what he sees as precisely as possible. And he reached for the most intense artificial light source on Earth and called it an aspiration. Reed Wiseman, watching the same thing through the same windows, trying to transmit what he was seeing to the ground team who could only listen, said, "There are no adjectives. There is a strange grammar to wonder, and it surfaces in moments like this one. The more extraordinary the sight, the fewer words survive the encounter with it. Language builds itself from shared experience, from the accumulated record of things enough people have seen often enough to need a word for them. The corona of a total solar eclipse, seen from 60 miles above the lunar surface, lasting 57 minutes, framing a moon that is itself framing the sun. There is no shared experience to draw from. There is no word that was built for this because no one had ever stood in this place before. The corona does not care about your vocabulary. It does not pause while you search for the right phrase. It simply exists, enormous and silent and white against the black, while two planets, Venus and Mars and Saturn and Mercury, emerged from the darkness around it, visible all at once in a sky that had no atmosphere to scatter their light. Two meteors crossed that sky during totality, brief streaks against the corona, and somewhere in the outer reaches of the field of view, the crew searched for the zodiacal light, the faint band of reflected sunlight from interplanetary dust that arcs across the inner solar system and is almost never visible to the naked eye from Earth. And the lunar surface below them was not entirely dark. There was a glow on the dust, faint and diffuse, from electrostatically levitated particles lifted off the surface by ultraviolet radiation, a phenomenon predicted by models for decades and still not fully understood, shimmering very slightly at the edge of the terminator. But the brightest thing on the moon's dark face was something else entirely. It is not sunlight. It is not an instrument artifact. It is light from Earth, reflected off our own planet and painting another world. And that light from Earth, soft, diffuse, painting the lunar night side in a faint cold glow, is something that the crew was not entirely prepared for. They had read about Earthshine. They had seen photographs of it the same way you have seen photographs of things that do not prepare you for their actual presence. But to see it from 252,000 miles away during a 57-minute eclipse with no atmosphere between your eye and the source, that is a different thing entirely. The light was bright enough to reveal surface features on the moon's night side, not a suggestion of terrain, not an impression, but actual features. Ridges, the curved edges of crater rims, the subtle texture of regolith that has been accumulating for 4.5 billion years. All of it illuminated by light that had left Earth, crossed 250,000 miles of vacuum, reflected off a world with no air and no ocean and no life, and returned something recognizable. Earth, in that moment, was saying something across the void, not in words, in light, and the message, if you let yourself hear it, was simply, "I am still here." The overview effect is a phrase coined by the writer Frank White in 1987, after interviewing astronauts who had returned from orbit. He was trying to name something that kept happening, a shift in perception, a reorganization of priorities, a moment in which the categories that structure ordinary life on Earth simply stopped applying. Borders disappear from up there because borders are a human invention projected onto a surface that has no use for them. Conflicts shrink because from the distance of the moon, the entire theater of human history occupies a disk so small you could cover it with your thumb. The crew of Orion Integrity did not need to be told this. They were living it. They were watching their planet, the one they had left 10 days ago, the one containing everyone they had ever loved, every institution they had ever served, every argument anyone had ever thought was important enough to fight over, reduced to something that fit inside a window, something you could frame with two hands, something that glowed quietly in the dark and asked for nothing except that you notice it. Reed Wiseman had been to space before, aboard the International Space Station in 2014, and he had seen Earth from low orbit, from an altitude where the planet fills your entire field of view and the curvature is a slow suggestion at the edges. That is not this. Low orbit is still Earth, seen from inside its own atmosphere's reach. What the crew of Artemis II saw was Earth at the distance the moon sees it, as one thing, complete and separate, suspended without support in a blackness that extends in every direction without end. And during those 57 minutes of eclipse, with the sun blocked, the darkness around that glowing planet was absolute enough that stars were visible in the same frame, which means that for the first time in their lives, the crew was seeing Earth the way the universe sees it, as a small bright object among an uncountable number of other objects. Remarkable mainly for the fact that anyone was there to look. Jim Lovell understood this. He saw Earth rise over the lunar horizon on December 24th, 1968, aboard Apollo 8, and he described it decades later as the moment he realized how precious and how fragile the planet looked. A blue marble in a black void, dependent on nothing but its own thin skin of air and water, and the particular distance it happened to occupy from a particular star. He flew again. He flew Apollo 13 and nearly died 2 days in, and he survived. And he lived another 55 years after that, and he died in August of 2025 at 97 years old, 2 months before the mission that carried his patch. The silk emblem from Apollo 8, the same mission, the same free return trajectory, the same gravitational arc around a moon that does not care about the names we give our spacecraft, flew aboard Orion Integrity. The physics has not changed in 57 years. The equations that carried Lovell and Borman and Anders around the moon are the same equations that carried Wiseman and Glover and Koch and Hansen. The universe is indifferent to the passage of time in a way that the humans inside it are not, and Lovell knew what the crew would see before they saw it, because he had seen it himself, and he had spent nearly 6 decades trying to find words for it, and he recorded his message for them 2 months before he died. A man of 97 who had been to the moon twice and nearly to his death once, and who still found the distance worth the risk. 53 years passed between Apollo 17 and Artemis 2. That is not a small gap dressed up in a large number. A child born the day Gene Cernan and Harrison Schmitt splashed down in December of 1972 would be a grandparent today. An entire human generation lived and worked and raised families and grew old without a single person leaving low Earth orbit to travel beyond it. The question of what humans would find when they returned, not the scientific question, but the human one, had been open for longer than most people alive had been alive to ask it. Christina Koch had spent 328 consecutive days aboard the International Space Station, the longest single spaceflight by a woman in history, learning what the body does when you remove it from gravity for nearly a year, and ask it to keep functioning. She understood the cost before she signed up for the longer journey. Victor Glover had flown to the station aboard Crew Dragon Resilience in November of 2020, and he was the first black astronaut to serve as a long-duration crew member there. And aboard Orion Integrity, he became the first black person to travel beyond low Earth orbit, which is to say, the first to go where the radiation is no longer partially filtered, where the magnetic field no longer partially protects, where Earth is no longer a presence, but a destination. Jeremy Hansen had never been to space before Artemis 2. He was a former Royal Canadian Air Force fighter pilot, a man trained to operate in high-stress environments with incomplete information and no margin for error, and he was the first non-American to travel beyond Earth orbit, carrying a flag that Apollo never carried, representing a country that had contributed to this mission and to every mission that preceded it, and never sent anyone past the atmosphere's edge. Wiseman had lost his wife. He had 2 daughters. He carried Carol into space the only way you can carry someone you have lost. In the choosing to go, in the naming, in the patch on the arm. Apollo never had this crew. Apollo flew 24 astronauts beyond low Earth orbit, and every one of them was an American man. That was not a reflection of who was capable, and it was a reflection of who was asked. The crew of Artemis 2 was the first answer to a different question, and Hansen knew exactly what that meant when he said, "Make sure this record is not long-lived. The record for farthest distance from Earth by a human being. The record for first woman beyond Earth orbit. The record for first black astronaut in deep space. The record for first non-American lunar traveler. These are records that exist to be broken by the next crew, by the crew after that, by the people who will one day look back at Artemis 2, the way Artemis 2 looked back at Apollo 8, with gratitude and with the quiet ambition of having gone further. They ate maple cream cookies behind the moon during the blackout when no signal could reach them and no one on Earth could hear them, floating in a capsule the size of a large living room, 50 minutes from the end of a 40-minute silence, watching impact flashes on a surface that had never stopped being struck. And then, the signal returned at 7:24 in the evening on April 6th, 2026, and Mission Control in Houston could hear them again, and they were already past the closest approach, already beginning the long arc back toward the planet that had been glowing at them from 250,000 miles away, the planet that had sent its light across the void as if to say, "Do not forget to enjoy the view." Those 6 words, spoken by Wiseman before the mission, carried differently now. Before the eclipse, they were an instruction. After it, after the corona and the planets and the earthshine and the crater, named for a woman who died of cancer and never saw the moon, and the patch that belonged to a man who had seen it twice and was now gone, they were something else. They were the whole argument, compressed into a sentence. What they brought back was not samples or data or photographs. What they brought back was the proof that the experience exceeded every instrument designed to capture it. What they brought back was a proof, but not the kind that sits in a laboratory or gets published in a journal, not the kind that requires calibration or peer review, not the kind you can point at on a graph and say, there, that is the result. The proof they brought back is older than measurement. It is the proof that comes from sending a person somewhere genuinely dangerous and genuinely alien, and having them return changed in ways that no instrument aboard Orion Integrity could quantify. And the thing that changed them, the thing underneath all the science, underneath the impact flashes and the magnetic anomalies and the asymmetric crust and the water ice in perpetual shadow, is something the moon has always been doing, silently, to every person who has ever looked at it from far enough away. The moon is patient in a way that biology cannot fully comprehend. It has been absorbing impacts for 4.5 billion years. It formed in the chaos of a collision between a Mars-sized body and the early Earth, and it has been sitting in roughly this orbital position ever since, gathering craters, cooling, drying, cycling through its magnetic history, and then losing that history entirely. And it has done all of this without urgency, without concern, without any awareness that a species on the planet 238,900 miles away would one day look up and decide to go there. 238,900 miles, that is the average distance, the number that anchors every mission plan and trajectory calculation, the number that represents the gap between the only world humans have ever lived on and the nearest world any human has ever visited. It is a number that sounds large when you say it, and becomes almost inconceivable when you drive it. If you drove a car at highway speed, 65 miles per hour, without stopping, without sleeping, without turning around, it would take you roughly 153 days to cover that distance. You would start in early spring and arrive in late summer, having passed through the equivalent of 5 months of continuous driving, and you would still be inside our own neighborhood, inside the same gravitational system, not even 1 light second from where you began. And yet from that distance, 238,900 miles, 153 days of driving, the entire apparatus that makes human life possible is invisible. Not small, not distant, invisible. The ocean that covers 70% of Earth's surface cannot be distinguished from the land beneath it except by color. The atmosphere, which contains every molecule of oxygen every human who has ever lived has ever breathed, which has been maintained at breathable pressure for hundreds of millions of years by processes so finely balanced that a small sustained disruption ends civilization. That atmosphere from the moon looks like a film, a breath, a blue mist clinging to a rock, not a protective shell, not a life-sustaining system, a barely visible coating on a stone, the way condensation clings to a glass. That is not a poetic description of what the astronauts saw. That is the literal geometry of it. The atmosphere is roughly 60 miles thick at its densest, and trails off to nothing over a few hundred more. The Earth is nearly 8,000 miles in diameter. The ratio is roughly 1 to 130. If Earth were a basketball, the atmosphere that contains all life and weather and history would be a layer about the thickness of a coat of paint. And that basketball is orbiting one of 400 billion stars in the Milky Way galaxy alone. 400 billion. A number that a human brain was not built to hold. A number that arrives in the mind and immediately becomes abstract because nothing in daily experience prepares you for it. But try to reach for it anyway. If you counted 1 star per second, without rest, it would take you roughly 12,700 years to count every star in our galaxy. You would have started counting during the height of ancient civilizations, counted through the rise and fall of every empire that has ever existed, counted through every war and every invention and every birth and death in recorded history. And you would still be counting now, and you would not be finished. That is the Milky Way alone. And the Milky Way is one of 2 trillion galaxies in the observable universe. 2 trillion. The number of stars in all of those galaxies is not something that can be spoken in a single sentence and felt. It is simply beyond the range of what language was built for. The moon has been fine for the entirety of that story. It will be fine long after every human city has crumbled to dust, after every road has been reclaimed by whatever grows in the absence of maintenance, after the last structure built by human hands has collapsed under its own weight, and the stone beneath it has been ground smooth by wind and rain over millions of years. The moon will still be there. The craters will still be there, some of them older than any life that has ever existed on Earth. The South Pole Aitken Basin will still be there, 2,500 kilometers across, 5 miles deep, the scar of a collision so violent that it may have restructured the entire internal chemistry of the near side. The Rena Gamma swirl will still be glowing in its preserved, unweathered brightness. The water ice will still be sitting in the permanent shadow of craters that have not seen sunlight in billions of years, colder than the surface of Pluto, waiting. The moon is not fragile. The moon does not need to be protected or worried over or saved. What is fragile is not the rock. It is us. What is fragile is the blue mist, the thin film of atmosphere, the narrow band of pressure and temperature within which liquid water exists. The 10 days that Artemis II spent crossing a distance that our species spent most of its existence not even knowing was crossable. 10 days from launch to splashdown, from the pad in Florida to the Pacific Ocean off San Diego, from this world to the edge of another and back again. 10 days in which 4 human beings looked at the surface of the moon from 4,000 miles up and saw impact flashes and an ancient Maria and the Terminator casting shadows hundreds of meters long, and then swung around the far side into 40 minutes of radio silence and ate maple cream cookies and watched the solar corona wrapped around the limb of the moon like a crown of white fire, and saw Venus and Mars and Saturn and Mercury all at once, and emerged back into contact at 7:24 in the evening and began the long arc home. 10 days. And they were transformed by it in ways that the mission objectives did not list and the instruments did not measure. Before the mission, Wiseman said, "Do not forget to enjoy the view." He said it as an instruction to himself and his crew, as a reminder not to let the checklists and the procedures and the monitoring consume the entire experience of being farther from Earth than any human being had ever been. But the view they got was not just a view, it was a mirror. Everything this mission revealed about the moon, the bombardment that has never stopped, the dryness that makes Antarctica look like a rainforest, the radiation that breaks DNA without announcement, the dead magnetic field, and the strange swirls preserved in its absence, the asymmetric crust that tells the story of a collision 4.5 billion years old. All of it reflects back not as facts about the moon, but as facts about where we came from, what we depend on, and how narrow the margin is between the world that produced us and the world that would simply let us die. The moon is not a destination, it is a mirror. And what you see when you look at it depends entirely on who you are when you look. Wiseman saw a crater named for his wife. Koch saw the beginning of something larger than her record. Glover saw a surface no one who looked like him had ever reached from this close. Hansen saw a confirmation that the flags people carry into space are not just symbols. They are arguments, made in the only language the universe takes seriously, which is the language of actually doing the thing. And every person watching from Earth, following the signal through the blackout and back into contact, saw the thin blue line of their own atmosphere from a distance that made it look exactly as fragile as it is. Do not forget to enjoy the view. It is not advice anymore. It never really was. It is the whole philosophy, compressed into 6 words, offered by a man who had lost the person he most wanted to share the view with, going anyway, looking anyway, carrying her name on a rock, 250,000 miles from the world where she was born. And so here is where it all lands. 6 flashes of light above an airless surface, each one a rock traveling faster than a rifle bullet and hotter than steel can survive, each one lasting less than a second, and leaving a scar that will still be there a billion years from now. A crew of 4 human beings at 252,756 miles from everything they had ever known, farther than any human being in history had ever been, beating a record that stood for 56 years by just over 4,000 miles. 40 minutes of silence behind a world that has no atmosphere to carry a signal, no weather to soften the surface, no field strong enough to stop the particles that pass through spacecraft walls without slowing down. A moon that wears two faces, one turned towards us since before our species existed, one hidden with a crust 20 kilometers thicker and a chemical composition so different from the near side that the two halves feel like they belong to separate worlds. Because in some sense they do. Because the collision that made the moon was also a collision that sorted its interior. And what Artemis II flew over was the scar that never healed. The Oriental Basin. The South Pole Aitken Basin, 1,550 miles across and 5 miles deep. The oldest and largest wound on the moon's surface. Older than any ocean, older than any continent, older than almost anything you could point to in this solar system. The shooting gallery that never closes, the two-faced world, the chemical coin flip, the magnetic tattoos pressed into the crust by forces we are still arguing about, preserved in the absence of the field that made them, strange bright swirls on a dark surface that have been visible from Earth since the 1600s and still do not have a single agreed explanation. Then, the eclipse. The sun slipping behind the limb of the moon, the corona spreading outward in streamers that no photograph has ever fully captured. The crown of white fire that crew member Hansen described by saying, "There are no adjectives." And that phrase is the truest thing said during the entire mission, because it is not a failure of language, but a confession that some experiences arrive at a register that language was not built to handle. The cosmic ray flashes in the eyes of 4 people crossing the boundary of Earth's magnetic protection, the retinal sparks that the Apollo astronauts counted and catalogued 50 years ago, and that Koch and Glover and Wiseman and Hansen now know from the inside. The Earthshine bright enough to read surface features on the night side of the moon. The planets, Venus and Mars and Saturn and Mercury, all visible at once in a sky that has no atmosphere to scatter the light into day. 2 meteors crossing that sky during the eclipse. The quiet of orbit. The maple cream cookies eaten in radio silence behind a world that for 40 minutes held them completely alone. And Wiseman, looking at a crater near Glushko that now carries his wife's name, Carol. A woman who worked in a neonatal intensive care unit, caring for the smallest and most fragile lives imaginable, who died of cancer in 2020 at 46 years old, whose name is now on the far side of the moon for as long as the moon exists, which is longer than the English language will last, longer than any institution currently standing on Earth will last, longer than the species that named it will probably last. That is not sentiment. That is permanence of a kind that the human world almost never offers. The crew cried. They said humility. They said that humans probably have not evolved to see what they were seeing. They said, there are no adjectives. And then they came home, splashing down in the Pacific Ocean off San Diego on April 10th, and the mission was 10 days long, which is not very long at all unless you understand what those 10 days contained. The moon is not just a destination, it is a mirror, and what we see when we look at it depends entirely on who we are when we look. What this crew saw was bombardment and silence, and the corona and the Earthrise and the chemical record of a collision 4.5 billion years old. What they carried back was something the instruments did not measure, and the mission objectives did not list. The knowledge in the body that the universe is indifferent, and that going anyway, feeling it anyway, naming things after the people you have lost and weeping in the dark anyway, is not a small thing. It may be the only thing that distinguishes what we do from what the rocks do. The rocks just fall. We go out to meet them, and we bring the names of the people we love. And we look, and we are changed. And we come home and try to explain it, and there are no adjectives. And we try anyway.